Discussions of dependence are everywhere in software engineering. Even though writers have been talking about it for decades in various books, like most terms in software engineering, it has never been defined. This leads to all kinds of confusion. We developed 9 dependency puzzles to illustrate this confusion, of which I'll present 3 right now. The framework puzzle. If A calls B, then A depends on B. So does this mean that a round-robin scheduler depends on each of the tasks it schedules? The crash puzzle. We'd like to say that if a change to B cannot break A, then that means A does not depend on B. But I can't change B to make it crash, so does that mean that every module depends on B, and every module depends on every other module because of crashing? The fallback puzzle. My system is going to use payment processor B, but if this processor fails, then it uses some other payment processor. Does that mean the system does not depend on processor B? In this work, we've made the notion of dependence more precise and answered these puzzles. The first thing to notice is that there actually are many versions of dependence, many different questions. And these can be given by 3 different parameters. The first parameter is the semantics of the program execution. For example, if you look at the static semantics of a program, the well-formedness, these can be used to formulate what are roughly build dependencies, whereas dependencies and the functional requirements roughly correspond to the program logic. The second thing is to notice that it's underspecified to ask if a module A depends on a module B. Rather, we must ask if a property phi of A depends on B. And this is enough to make progress on the first of the puzzles. So many of the runtime properties, such as execution time for the scheduler, do depend on the tasks, but its overall correctness is not. But we're still not done because certain changes, such as making a task not terminate, could hog the scheduler and hamper correctness. So this brings us to the next parameter. We like to say that if A does not depend on B, then no change to B can affect A. But there are many caveats, and so we're kind of left with the tautological reduction, unless that change introduces dependence. While we might like to eliminate some of these changes from consideration, in other contexts that is not permissible. So the final parameter is to give a superspec, which is a constraint on what changes may be considered. And this finishes that puzzle, in that we can choose not to consider changes to a task that do not terminate. And it also finished the second puzzle. We can consider whether or not to consider changes that crash, but it's not addressed the fallback puzzle. And for this, we have a big insight that the fallback puzzle, using a different payment processor, is isomorphic to this example. It rains and the grass is wet. Does the grass being wet depend on the rain? If it didn't rain, the sprinkler would have come on. Examples like this have been studied for a long time by causal inference researchers. And in fact, we find that all of the examples that we've given, all the puzzles in the paper, are isomorphic to some scenario involving physical causality. And so we argue that dependence and causation are the same thing. And this is great news because we can simply look up some of the results from causal inference. As a quick intro, causal inference deals with causal graphs, which are roughly straight-line programs. Here's a causal graph for the sprinkler example. There's already extensive research that gives logical definitions to determine whether an event is a cause of some property being true. By applying this to the fallback puzzle, we can in fact determine that in an execution where the system did use processor B, the success of the payment did depend on processor B. We do a lot more of this in the paper. In fact, from a single formal definition, we are able to recover many different kinds of dependency, and we also have some insight into the nature of coupling. For more information, come to the talk or read the paper.